Well, good morning, Cisco Cohort 2. Welcome. It's Monday morning, 9 o'clock, time to start get going. Tarrant, welcome to this Tarrant College South Campus presentation of the Cisco Networking Academy Introduction to Networks 8-week curriculum that we're going to be presenting here. On the schedule for today, I'm going to cover what they used to call chapters, now they call them modules. Modules 1 and Module 2 on some basic networking concepts. And then in the second Death by PowerPoint presentation, we'll look at some basic switch configuration iOS commands on the switch. Let's go ahead and look at how administratively, academically, this class is going to run this semester. So let's see, I'm going to go ahead and go to should show the announcements. Okay, so what I'm looking at is the My TCC Blackboard LMS, Learning Management System. And here we see in the left-hand column, in the upper left-hand portion, the announcements, you guys all got a copy of this email announcement. So we're going to be meeting on Mondays at 9 o'clock a.m. for lecture classes, remote lecture classes. And these lectures will all be recorded, and I will post them in the recorded presentations link, which is, I must be seen here, it'll be posted down here. So when you look at the recorded presentations, I've got a few videos already posted in here, like how to go to the student workspace on the virtual, the VDI virtual machine link, which has a packet tracer already installed on it, or you can download and install packet tracer on your Windows or Macintosh machine. You can even install it on a Linux machine. It'll work away as well on that. So as the lab demonstrations and the Wednesday lab demonstrations and the Monday lectures are recorded, they'll be posted on here and very soon after that particular class or lab takes place. Pardon me. So this is Introduction to Networks, and this course will go through Wednesday, May the 12th. At 9 a.m. and that's when the final work is all due. We're going to look at the ICR and look at the details on that in just a second. Okay, when you click on the next tab, My Grades, this shows the, I get to use two LMSs. I get to use, and you guys get to use, both the Blackboard LMS, which is the LMS that we officially punch our final grades into at the end of the semester. We're switching to Canvas, which most of the public schools are using in the fall. And we'll also be using the Cisco Networking Academy LMS, which used to be Canvas, but now is Moodle. And I'll give you a link at that as well as we go into that. So the grading on this course is 50% for laboratories and 50% for some end of module exams and the final exam that will be taken on the Cisco Networking Academy site. So there's, let's see, I think there's 1, 2, 3, 4, 5, 6, 7 labs. I do drop the lowest lab score, so you can safely skip one lab and you won't lose any points. Now we have a course evaluation link, which will take you to the Web Advisor. It's like a student satisfaction survey, which we normally ask you to take that toward the end of the semester. That's not mandatory. Now there is a student satisfaction survey on the Cisco Networking site called Course Feedback Form that you absolutely must take to take the final exam. You have to take it before you take the final exam. And right now we're in the midst of Blackboard Collaborate Ultra. I'm going to skip the class syllabus. I'm going to go back to that in a second. So the course presentation materials, this is popping up on your screen. Okay, good. This is all the Death by PowerPoint slideshows that I'll be using throughout the semester. So today we're going to look at a stripped down version of networking today, and then we'll look at the switch iOS config. Student lab printouts are the labs, and let me count again. That right, 1, 2, 3, 4, 5, 6, 7 labs that we'll be doing. And then I also posted this user's guide for how to log on to, in the left-hand column, when you first log into My TCC Blackboard, on the left-hand column, there's a link for Student Workspace VDI, which you can run Packet Tracer on virtually. Even if you got a crummy old 1 meg Chromebook, it'll work fine for that. If you got a halfway decent machine that's at least 10 years old, you should be able to install Packet Tracer on that machine if you'd rather install it and have it present on your own machine. There's some chapter study guides. Now these guides don't kind of line up very well with the They used to be chapters, used to be 11 chapters. Now it's like 20 modules. So they split it up a little bit. But these are some Microsoft PowerPoint study guides for some of the topics that are covered in these various modules, as they're called now, instead of chapters. And then at the bottom is a link to the district syllabus. Let's go straight to the ICR, because I want to show you, that's what we were just looking at a second ago for the schedule. So this is the stuff the lawyers make us say. Okay, so this is CCNA 2 course, which currently is Introduction to Networks, ITCC 1440. And there's me up there. I go by Mark, not William. William's my first name. I go by my middle name, Mark. And we're very liberal about refund dates and drop dates. And you can drop this date all the way up to April the 29th if you decide this ain't for you. And here are my office hours that are listed. When we come, if you want to come to the Wednesday Labs, that's on the South Campus of Tarrant County College, 5301 Campus Drive in South Fort Worth. And we'll be in the SBUS building, SBUS 1125, on the bottom floor. Look for the electricians running around the building. Electricians are replacing all our lights with LED lights. So they're really very busy on that stuff. Sometimes even the fire alarm goes off right in the middle of class. Okay, now the books in this course, it's going to be an ebook. And now it's not going to be like the ebook. When you took that Computers for Terrified Adults class, computer literacy class, that's what I call it. You could buy an ebook, and the ebook sort of vanished into smoke the week after the final exam. But Cisco has been given, I've been teaching Cisco for, this is my 22nd year now. I started teaching it in 2000. Cisco has been providing all their Cisco Networking Academy. But by the way, did you know that the Cisco Networking Academy is the single most successful e-learning initiative in the entire world, in the entire globe? We've had over 10 million students pass through our doors. There are 10,000 academies worldwide. And we have always given you a free ebook, and it will last forever, and it won't go away after the class is over. So Cisco has provided a website called netacad.com that you can go to, and that has the free ebook on it. And that's also the website you'll go to take the module exams. There's 6 module exams for this particular course, and there's a final exam, and that'll be taken on the Cisco Networking Academy site. So you're given access, pardon me, you're going to be given access to that website, no charge, all for free. Well, not exactly free, you pay tuition. By the way, did you know that the tuition that you pay for this course is about 1/6 of the actual cost? You guys pay around $60-something a semester hour for tuition. The actual cost for us to give it to you is about $360 an hour. So it's like a 87% discount. Where does the rest of the money come from? Well, we get the rest of the money from property taxes in the Tarrant County and Austin census some as well. Hold on, some other people logged in. I get to do a roll because I send Austin pieces of paper telling who came to the class. They put it in a filing cabinet and never read it, and they send us $60 million a year. So that's a pretty good deal. All I got to do is take attendance. So Introduction to Networks is the course that covers basic networking technologies. We're going to look at switches, routers. From the CCNA standpoint, these courses in the Cisco Networking Academy are designed to prepare you to get the Cisco CCNA, Cisco Certified Network Associate certification exam. You go to View Prometric and you pay a fee. And by the way, we'll give you a discount, 2/3 off of that if you get us over a certain grade on a certain final exam. And then you get certified by Cisco as being a CCNA. And that's a great job certification, marketable skill type of thing. CCNAs are in big demand in the Dallas-Fort Worth area. Cisco has a thing called the Career Bridge that can help you hook up with employers. And if you have a CCNA certification, you're going to have a much easier time finding a relatively well-paid job in the Dallas-Fort Worth area, working for people that sell Cisco devices and install Cisco devices and so forth. So to be okay in this class, now we used to have this rule before the COVID idiocy took place. You had to come to all the classes and you had to come to all the labs. Well, now we record everything, and you can either, you can be online with us right now in sync, or you can watch it later because everything's recorded and put in the recorded presentations page. So you can come Wednesdays live in person on campus. I'll be there. I'll be there in SBUS 1125, and you can get your grubby grimies on the real live Cisco equipment. But if you don't want to come, that's fine. You can do it buy a packet tracer and just turn in that student lab printout Microsoft Word document file with your answers that you've typed into there for me. So some of this stuff is up here when we have real on live attendance all the time. But to be successful, we do have what I call attendance forbearance. You don't have to actually attend any live sessions. You just have to do the work. And the work is 50% of the work is doing the 7 laboratories and turning them into me. And the other is doing the 7 tests, the 6 module exams, and the 1 final exam on the Cisco Network and Academy, and you'll be able to get a good grade in the course. Okay, so I told you this before, it's going to be 50% for labs, and I do drop the lowest lab grade. And then 50% for, oops, there's a mistake there. Ooh, it used to be 11 chapter tests. Now it's going to be 6 module tests and the final exam. And by the way, all these tests are open book. And if you, the policy we've had for 20 years here at the computer science department is the final exam grade can substitute for a previously missed earlier exam. So there's 6 module exams. If you only take 5, that 0 is not going to hurt you. I'll just take whatever you made on the final exam and make that your 6th grade, and that won't hurt you so bad. 5 for rounding, just like the IRS. We don't give A minuses and B pluses. We just give standard A, B, C, Ds, and Fs. So if you get an 89.5, I'm going to round that up, and you're going to give an A. If you get a 79.5, I'll round that up, and you get a B, etc. Okay, so every Monday we'll have our lecture class, live lecture class, or online remote class. I'm live here in front of the camera, in front of the screen with the projecting stuff to you using Blackboard Collaborate. That'll be recorded, and you can review that later, or if you miss it, you can watch it later. Wednesdays will be the in-person labs. It's SBS 1125. And at the beginning of the lab period, I typically will record what I call a lab walkthrough video showing what's happening with that particular lab on the real live Cisco equipment. And sometimes I'll even record it what it looks like in Packet Tracer, because some of you guys will be doing it on Packet Tracer. So if you don't wish to attend any laboratory, a particular lab session, or any of them, or some of them, or all of them, it's up to you. You can do it using the Packet Tracer software, and that's free software you can get from Neticat. So here's our schedule. Today we're doing modules 1 to 2. I'm doing this introduction. And so there's some stuff down there the lawyers made us say. I'm not going to dwell on that right now. Okay, let's see now. I need to show you guys the Cisco Network and Academy site. Let me see if he's going to let me do this. Hang loose 1 second here. I'm going to go back to here. I'm going to go back to here. And hang on while I bring up the Cisco Network and Academy site. We're walking, we're waiting, we're watching. Got to key in my secret stuff here. Okay, now I should be able to go back to here, and I should be able to share the application of this. Okay, I've logged in with a sort of a fake student account, because teachers, the thing that teachers see when they're at the site is a little bit different, like, you know, being able to change your grades and stuff like this. So these are the 2 courses I'm teaching this semester. This is our course right here, Introduction to Networks. I also teach a more advanced Cisco course on Tuesdays and Thursdays. So what you can do when you go in here, why isn't it letting me click? There we go. So the launch course, sometimes you have to sort of click to bring it to life here. So here, launch course, I'm going to launch the course. And this is the main splash screen, the main greeting screen for this particular course. So we're going to start covering modules 1 and 2 today. We're going to do some basic network connectivity and a little bit of introduction to some network concepts. And you see that the first test here is covering modules 1, 2, and 3. Well, we're not ready to do that yet. We're just going to cover modules 1 and 2 today. I'll cover module 3 next week, and we'll cover, as we step through this course here, we're going to cover all these modules. So let's say there's 1, 2, 3, 4, 5, 6 little module tests to cover all 17 modules of this, instead of the old 11 chapters and 11 tests that we used to have. Now, this course feedback thing I mentioned earlier, you must take this course feedback sometime just before you take the final exam. You notice here on my fake student account, I can't take the final exam because I haven't completed the course feedback form. The course feedback form is a student satisfaction survey that I can't see, just like our Web Advisor student satisfaction survey, I can't see any identifying information. This is your one chance to comment about my choice of bath soap and say anything you want to say whatsoever, and no one will be able to know who you were, and I won't be able to see anything until after final grades are turned in. So Cisco will ask you questions like, how well do you think this prepared you to further your academic career in networking technology, or prepare for a job in technology and stuff like this? And then me and the Cisco's interested in doing this because with 10 million students, they want to track how they're doing. So to be able to get the course, it's kind of weird to see, but you're going to click on this part up here. And then we're going to check on the course content. And let's see, is that showing up on you guys' screens? Okay. So this is our ebook, a little ebook here. So you can go through here and start reading the content. And let me show you the real handy index function here. You can click on the index, and you can zoom and see the whole thing, the whole enchilada here. If you want to see, for example, I just want to look at the videos. You can click on here and then click on the videos, and then they'll show you just the videos that are in here. So it's a very handy index function. Okay, I think I've showed what I need to do on that. Let me go back to this. Okay, I've showed the Cisco Networking Academy LMS, and I've showed the Tarrant County College My TCC Blackboard, and now it's time to actually do some PowerPoint. So I'm going to share a file. We're rolling? Yeah, we're rolling. Good. All right, good. Okay, so I'm going to cover 2 PowerPoint slideshows today. This one's a little bit brief. It's only about 15 slides. And then we'll cover the second one, which covers the iOS stuff, which some of you guys that were in my previous class may have already seen this before. Some of this, a little bit of this before. So clients and servers. Do have this concept of technicians and engineers usually call them hosts. Technically, a host is any device that connects to a network and has an IP address. Sometimes called in devices to differentiate that from intermediary devices. In this diagram, the switch is the intermediary device because it makes the path determination decision and connects everything together. And these servers and client machines, these are in devices, or the buzzword now in Cisco is it's an endpoint. I've got my laptop endpoint. So endpoints create data and receive answers to that data. So an email client, for example, could send, or that web client in the upper left-hand corner, he could request a web page. He started a flow of information going. That's what that guy did. And then it flowed through the switch, and the switch made the connection to the server. The server took the request and provided the answer back to the client machine. So intermediate devices themselves, they don't create data themselves. They just choose the best path. The data is created, requested, and returned by client and server machines. Now let's talk about Microsoft's definition of peer-to-peer and client-server. He says client and server software usually run on separate computers. So for example, you would run a client web browser software on your desktop, Windows PC, and you would log on to some web server like the Cisco Netacad server or the Microsoft.com server or the whatever server you're trying to connect to say something. Usually they're separate computers, usually in different places. So Microsoft says that to be a client-server based network, let's talk about peer-to-peer first. A peer-to-peer is where there's no dedicated file server or no dedicated client machine. So in a home environment, a small business environment, it's taking a look at this diagram. We've got the user who has a printer connected to him. And maybe in a small business, this is the guy who's the accountant for the company. He has to print accounting reports. So he has a very fast laser printer attached to him. And he's not running a server. He's just running Microsoft, the regular Microsoft Pro workstation computer, software on his computer. And his printer is directly plugged into the printer port of his computer, and he can print to the printer. Now, other people, this is a small company, they can afford to buy laser printers for everybody. Well, the laser printers are pretty quick. One laser printer can serve several users at the same time. So that user that's running the print sharing computer, he can right-click on his computer and share the printer. And then everybody else can see that. They can go into their network neighborhood. They can go from their computer. They can share stuff. So the guy in the middle is sharing the printer. The guy on the right is sharing files. Maybe he's sharing the accounts receivable file, and he needs to print it. So Microsoft, it's very easy to simply right-click on something and share it. And if you want to set a password, you can do that. If you want to do security, you can do that. Or you can simply make it available to everybody you need to. In small businesses, typically not very much security. You go in the break room, and on the coffee machine, there's the list of passwords for everybody, or there's no passwords. So this print sharing guy, he's being a server and a client at the same time. He's running a client program, and he's also serving up the printer. The PC on the right, he's serving up the shared files for everybody else to see. So these are peer-to-peer based networks. They're easy to set up. They're very not complicated. Just right-click and share it. Low cost. I didn't have to buy a dedicated file server. I didn't have to hire a Microsoft system engineer to set it up and run it for me. On the downside, there's no centralized administration. You got to remember, everybody's got to remember what's the password for the printer. And if the guy who's got the printer attached to him gets mad at the accounts receivable clerk, he'll change his password and won't tell her. And now she can't print. In the same vein, the person that's running the file sharing computer, if they're get mad at the accountant with the printer, well, he'll change the password, won't tell him. So there's no centralized administration of passwords. In a big company, you always have a system administrator who has access to reset people's passwords, and they only have to put in one password to get to everything. Not a printer password and not a file sharing password. This system is not scalable. In other words, Microsoft says that if you have more than 10 or 12 people in a setup like this, it becomes unwieldy, it becomes unworkable. It's too much stuff going on. And we have slower performance because the guy who has the printer directly attached to him, and the printer starts printing a big print job, it demands CPU cycles from his computer to do that, and it slows down whatever he's doing. So if it's over 10 or 12 people, Microsoft recommends that you go to a client server-based method. It's where you have dedicated servers. Of course, that means you have to hire a dedicated system administrator to run them. But that's going to give us much better performance, centralized administration, and higher security, and better performance at everybody's individual PC because their PCs won't be hung up with, running print jobs for everybody. Okay, let's look at these three types of network components. So I could simply take a cable and plug two devices together. Okay, you get a new computer and you want to back up everything from your old computer to a new computer. You can just plug them together with an Ethernet cable. Turn on file sharing, right-click and share everything on the first computer, copy to the second computer. Are you ready to go? Very simple network. Or it could be a more complex computer like this is showing two different offices. No fair. We haven't talked about LANs and WANs yet. What the heck does that mean? So a local area network is like the network at one office. So the yellow LAN on the left may represent, South Campus. And the yellow LAN at the right may represent the Northeast Campus. And, the question has popped up on the screen here. Hold on. Someone says, do you need a special Ethernet cable to connect to? That's a great question. Do you need a special Ethernet cable to connect two devices together? Hang on. Someone is logged in here, and I need to make sure I got everybody. I think I got everybody already. So most modern computers, it used to be over 10 or 15 years ago, you had to use a special. We're getting ahead of ourselves. We'll have a chapter on this later. Used to use a straight through cable to connect Ethernet devices like PCs to a switch or a hub. And you would use a special crossover cable to connect two like devices together, like from a switch to a switch or from PC to PC. Most Ethernet circuits in the past 15 years or so, for about pretty much the past 15 years, have gotten really smart. And there's a feature called Auto Mdix, which means that if you plug in a straight through Ethernet cable when it should have been a crossover cable, or you plug in a crossover cable when it should have been a straight through cable, as you pointed out there in the chat, AIAT, I568A and B, they'll still connect up. The little transistors inside the Auto Mdix will gin up the proper connection, and even if you use the wrong cable type, they will make the link lights light up. So now when we have our labs, when we plug two routers together and where we plug two PCs together, they're going to work just fine. Now someone said, what is Wireshark? I thought they were talking about SharkBite, the plumbing thing. Wireshark is a program that can sniff the packets on the wire and show you what's going on. So if you're using a really insecure protocol like FTP or Telnet, you can see people's passwords. That's not secure. But in the labs, we haven't isolated. Oh, by the way, there's a big problem with teaching networking in schools from the standpoint of us teachers. The administration, of course, has got to run a secure network because they've got to comply with, we've got to comply with the Family Privacy Act, and you should be able to find people's social security numbers and things like that. So their administrators and upper managers are looking at us and saying, wait a minute, you guys are going to teach the guys how to Wireshark and see all the data on the network? And you're going to teach them how to break into servers and change their grades to all A's and issue themselves $1,000 tuition refund checks? Oh, we can't have that. No, no, no. So how do we get past this and still got to teach you guys to make and break things on a test network? So what we do at the college is we have an isolated air-gapped rack of network devices back in the back of the room, SBS 1125. And it's not connected to our real college network. So you can do anything you want to. You can set up a protocol and you won't get the librarian mad because you're messing all the machines in the library. We're totally isolated from the rest of the campus and the rest of the world. Okay, so three things: devices, the media, and services. So let's look at these three particular things. So we have our devices, our end devices. Let's go ahead and I think we'll go to the next frame here. Devices. So the devices are, I think, our endpoints and our switches and routers and things of that nature. We have devices that are connected. We have media. The media is those dark black wires. Could be Ethernet copper cables, could be fiber optic cables. And then on these devices, we have software processes running. Like on your PC, you have the Microsoft Windows operating system, which has network connectivity, lines of code built into it. The Cisco devices are running the Cisco iOS operating system, which has their connectivity functions built into it. So end devices are the devices where the message originates from or where it's received from. So you click on a send button and you started the flow of data going. And let me see, hold on, I'm gonna review the chat messages here. I can't see them all at once at the same time. Let's see, got several chat messages here. Okay, so I talked about Wireshark. We talked about the crossover and other cables, which we'll get in a later chapter. Okay. And let's see, I've got attendance. I think I've got 1, 2, 3, 4, 5, 6, 7. I think I've got 1, 2, 3, 4, 5, 6, 7. Oh, good, $60 more million from Austin. So data originates from some end device, like when you click on a web link. It flows through the network, through the intermediary devices, such as routers and switches. And eventually that little packet will arrive at an end device. And if it's a server, he'll respond to your server's clients request services, and servers fulfill these requests for services, and you'll get an answer back. You'll get that web link that you clicked on. So end devices transmit and receive data. And he says here, messages can take alternate routes. We're going to go to the next page. There we go. Okay. So intermediary devices are things that your home router as an intermediary device. It connects your home network to the internet service provider that you're getting probably from your cable company. I get mine from the phone company. So intermediary devices are the things that make the best path decision. And they also are responsible for gussing up, as we're saying in East Texas, gussing up the bits, the electricity on the wire that represents the 1 and 0, and detecting errors and things of that nature. So network media is the things that plugs it together. We have 3 basic types of network media from the CCNA objective standpoint that we're interested in. Those are copper wires. We talked about crossover cables and straight through cables. Copper wires are metallic copper that's in insulated wires, and there's a certain color code to them. Someone mentioned the EIA, TIA 568A and B. Normally everything's on the same color code, like everything's A to A or B to B. If you do A to B, you get a crossover cable. I'm getting ahead of myself. Fiber optic cables don't use electricity. They have pulses of light that travel through these strands of hair-thin strands of fiber optics. And these strands, like a light, a flash of light may mean a 1, and a no light might mean a 0. And the third thing we're interested in from the CCNA objective standpoint is wireless transmission radio waves, like Wi-Fi, which use radio waves to transmit wirelessly from one point to another point. Okay, LANs and WANs, here we go. So a local area network is the network that's within, at the South Campus, it's the local area network that's in our building. And everything is plugged together. We have a wiring closet out in the hallway. All the 200 or 300 computers in the building are plugged together into that wiring closet. And that's operated and owned by the college district. Our chief network engineer decides what brand of equipment to buy and what protocols to use and so forth. The 3 things, local area network is very high speed, dedicated 24-hour day connectivity, and owned by an organization. Now, wide area networks, we don't have the ability, we're a government, we're a Texas state agency, but we may not go out and dig a trench between the Southeast campus and the Northeast campus and run our own wires. Only the telephone company can do that. So if we need to connect together different campuses, we need to lease bandwidth. We need to lease telephone lines from one location to another location to connect us all together. So a wide area network is something that's usually owned by a carrier or a service provider that connects us together. You have to go to the cable company or you have to go to the phone company to get a connection to their wide area network that goes to the internet and other locations. So we lease, back in the 90s, we would lease T1 lines to go from one location to another location. Nowadays, those were on copper cables. They weren't that fast, 1.5 megabit. These days, fiber optic cable has much higher speeds. And if you live in a neighborhood where you can get fiber optic cable, you generally can get like a gigabit speed, gigabit up, gigabit down. We have to lease that and pay a recurring monthly charge for that. Other types of network in the Dallas-Fort Worth area, which is a thickly settled area, you can get something called a Metropolitan area network, which is a type of network where you'll lease a line from a company and they'll put a little box with an Ethernet jack on it, and you can just plug it into your network at that office and then plug it into the network at the other office, and they're connected together. Wireless LANs, WLAN, in some areas of the country where the cable companies or the phone companies don't want to compete because they can't make a big profit. Small entrepreneurs, small businessmen can put up like WiMAX type towers, say on the west side of Galveston Island, where the cable companies won't go because there's nothing there but rattlesnakes and mosquitoes. You can go there and go on a vacation home and pay a daily charge and get your internet connection while you're on the vacation. Okay, storage area network, SAN, and its dyslexic cousin, network attached storage, NAS. These are big banks of disk drives that in a data center with lots of rack-mount computers, instead of putting individual disk drive storage in each individual computer, we have a specialized computer that's a whole bank of disk drives and all the other servers carve those up and use those for the individual distros. It saves the company money in the long run. Okay, 3 characteristics of LANs: small geographic area, your house, a school, an office building, a campus, usually administered by a single organization or individual, and fairly high-speed bandwidth to all the devices that are present within the network. So most modern home routers are gigabit Ethernet connection speeds to all the devices they're plugged into. Wide area networks, that little red jagged lightning bolt figure, that represents the stuff that I don't have direct control over. I had to lease that telephone line connection or that data connection to another location. And I leased it to at a certain rate of speed, a certain monthly recurring charge to get that. So WANs connect LANs, individual LANs together. Maybe the one on the left is the South Campus, the one on the right is the Northeast Campus. Different service providers will provide these links. Now, this WANs typically provides slower link speeds between LANs, and these rules are starting to change. Back in the 90s, Ethernet was 10 megabit, and the fastest WAN connection you get was like a T1, 1.5 megabit, but 7 times slower. However, these days, it's possible that, for example, our junior college network, we have gigabit Ethernet to all the workstations in the student lab, in the Cisco lab. The connections between the different campuses are 10 gigabit. So actually, the WANs are now faster than the LANs. And this is a big benefit to network engineers, because now we're doing what most companies have done. We put all our servers downtown at the Trinity River Data Center. They don't have to be in the various departmental workgroup servers like they used to be. Okay, internet connection of, okay, we have our cloud figure here. And generally speaking, when you draw the cloud figure, it refers to, there's a whole bunch of stuff out there, and I can't log into it and configure it myself. I have to pay somebody else to run it for me. So there can be all sorts of different devices connecting everything together with. Internet is a bunch of LANs connected together using a bunch of lease circuits. And they use copper. They can use copper cable, use fiber optic cable. They can use wireless transmissions. And the internet itself is a whole global thing. It's not owned by any individual government, although the United States government acts like they own it, and they should be able to run it. So there are some groups that help, volunteers that help run this stuff since the beginning. Internet really started to take off like in the early 90s. So the Internet Engineering Task Force and ITN people, which are the people that provide domain names and IP addresses, and the Internet Architecture Board have all a bunch of smart guys that all stayed up late one night and wrote all the protocols that make the internet do what it did today. One of the 2 big killer applications on the internet today, web browsing and email. So an intranet is a net within the company. It's only for company people to use. If you go to the Tarrant County College website, you'll see something called Inside TCC. You can't get to it. You don't work here. If you work here, you can log into the Inside TCC, and that's our company intranet, where we can see what our human resources benefits are and how to do an assurance claim and things like that. The extranet is something that a company would have where the people that send them supplies or people that buy things from them or their business partners, they could work with them. So for example, think of, Amazon. Amazon has lots of customers that buy stuff. Amazon has lots of suppliers that fill their warehouses up with junk that you buy. So that Amazon is an extranet. You have to have an account on Amazon to log in and be able to buy stuff. And then we have, encompassing all of that, the entire internet as a whole, the whole world of the internet itself. Okay, new concept, fault tolerance. Fault tolerance is, any of you guys take A+ build computers? I see a couple comments in here. A couple of you guys seem to be technically savvy. I want to build a server for my company, and I want to build it in such a way that if the disk drive goes bad, I don't lose the single most important file in my entire company. What file is that? The accounts receivable file. Oh, if I lose that one, I don't know how much money my customers owe me. So I'm going to do a couple things. I'm going to put in a RAID drive array, which is I'll take 5 disk drives and strap them together. And if any one of those disk drives has a physical failure and the smoke comes out of it, I haven't lost a single bit of data because it's been redundantly backed up on all the others. So that's fault tolerance. That fault tolerance, the idea is any one thing can fail or burn up or whatever, and company operations will continue. So we do, with our company data on our servers, we use RAID drive arrays. We use UPS backup power supplies on them so that computers get nasty if you just pull the plug on them. So the UPS, if there's a power failure, it'll keep it running properly. In networking, what we do is we have multiple paths. So in this diagram, we've shown the normal path. This user is coming on the green line to his work group switch, and is going to his router, that round thing, and then the router that he normally uses on the internet has failed. But he has an alternate backup path to another router, which gives him another connection to the internet, and he can continue generating revenue for his company. So redundant connections gives an alternate path. The user himself probably will never even notice any slight delay whatsoever. Now, the concept of scalability means that when I talked about peer-to-peer networks, they don't scale up above 10 to 12 users. It's unwieldy. I can't remember 7 passwords. You know, I used to do support where I changed people's passwords. I ran an old Novell network back in the 90s. And some people just can't remember one password, not alone 7 or 8. They have trouble remembering just one password, because the idea with Microsoft is you use one password and you get access to everything the network administrators are giving you, system administrators are giving you access to on that network. What if you had to remember one password for the printer and another password for the shared files? So if you want to change your Network and Academy password to be the exact thing as your Tarrant County College web advisor password, you can do that, unless you like to remember lots of passwords. So scalability refers to we can add to the network without having to throw everything out all over again. So in this case, on the right of the diagram, we've added a new building. So like at the South Campus, we recently put in a new air conditioning building back in the corner, and we were able to add on that without having to scrap our entire existing network. We just added more Cisco devices and fiber optic cables and plugged it in. By the way, we're pretty much a Cisco shop. Most companies go with one brand or another because all the technicians can be familiar with just that one brand. One of the great things about Cisco is the iOS operating system that you type in the configuration commands on, pretty much the same on any Cisco device. We're going to do the switch first. Later on, we'll do the router, almost exactly the same. So that way, the technicians don't have to know one operating system for a Cisco device and another operating system or menu command for a Hewlett-Packard switch or whatever. So we can scale up. We're a Cisco shop. Everything is Cisco routers and switches in our company and our junior college district. And we're pretty much a Microsoft shop for all the software. We have all Microsoft servers and all Microsoft workstation stuff. Oh, we do have some Macintoshes in the library if you want to do that stuff. I'm actually doing this. I'm doing this presentation from Macintosh, actually. Quality of service is a concept that some data needs to skip the line and go to the head of the line and be treated first. Otherwise, it's going to cause a problem. And usually this applies to things like, streaming audio, streaming video, telephone conversations. They don't need a lot of processing power and data, but they do need very low latency, very low delays. So what we can do is all the voice over IP telephone sets, we use over Cisco telephones in our enterprise. All that stuff gets put at the head of the line. Very small chunks of data. Doesn't take much bandwidth for a phone call, but it can go ahead of other data. If someone's downloading a gigabyte of data for a Service Pack 1 for Windows 10, and it's delayed a quarter of a second, no one will notice or care about this. So quality of a service, we're going to learn in a later course, particularly how do we configure and program our routers and our switches to make sure that the Cisco voice over IP telephone traffic or the marketing manager's monthly teleconference, video conference, and all the other stuff gets priority and is handled first. Otherwise, you get, you know, it looks like in YouTube when you get the scrolling and it's like a cheap Walmart cell phone. So we're going to do quality of service. Not in this course, just as concepts. In a later course, we'll do the actual code for this. Okay, security refers to a couple of things here. We want to have security on the network devices. Now we're going to use this particular pair of passwords on all our labs. Cisco and class. It's a Cisco class. In the real world, you will not use Cisco in class because everybody, all the 10 million students that have taken Cisco know it. They can break into your network. You're going to use a harder password than this. So we're going to set passwords to protect you from being able to plug into a network device when you're touching it or telnet into it from real location and do stuff to it, just to prevent unauthorized access to those devices. And we also want to protect our company data, our information that our company has. Like, for example, we have some very strict federal regulations we must comply with to protect student privacy. So here are the 3 tenets of security. CIA, Central Intelligence Agency. No. Confidentiality means you can only read the data if you're supposed to read the data. How can I tell that you are you? Well, you logged in with your password that only you knew. Integrity is the data hasn't been altered on the hard drive it's stored on or as it went over the network connection to the location. So if I send you the Chase Pay thing for $100 because I broke your window with my baseball, you can't alter it and get $1,000. It won't work. You can't change the data. It won't pass the test. It won't pass the integrity test. And availability means I can get to the data when I need to get to it. No denial of service attacks, other things. Okay, you know what hacktivists are? Okay, an activist is someone who has a political agenda or a social agenda. A hacktivist, with an H in front of it, is someone that is an activist with a social or political agenda who is a skilled hacker, and maybe he's decided that on Prime Day, he doesn't want Bezos the Beast to make an extra $1 billion of profit today, so he's going to get him and 50,000 of his friends to hack into the Amazon and stop them. So that's denial of availability. So that means that companies have to do things to try to reduce that type of problem. Okay, hang loose. I'm going to stop this brief abbreviated module 1, and we're going to go to module 2 and get into the nuts and bolts of the iOS. Okay, basic switch and end device configuration. What is our switch? Our Cisco 2960 switch. End device is like a desktop PC, like a Windows PC. Okay, so we're going to look at the Cisco device. How do you access it and start putting your configuration in the first place? We're going to look at how you navigate through the iOS, its command structure, and we'll configure it using just some basic stuff. You know, give it an IP address, give it a password, save that configuration. Then we'll look a little bit how devices communicate across network media like copper or fiber optic cable. How do you configure a host device with an IP address, and then check connectivity like using ping between various devices. Okay, the Cisco iOS operating system. All operating systems have a basic hardware. Let's talk about your Windows desktop machine. It has some basic hardware. It has an Intel chip, maybe. Has RAM memory, has a disk drive, has a motherboard, has some hardware that's all soldered down to that motherboard. That's the physical part of the computer, all the electronics parts. And then in the Windows operating system, there's something called the kernel, which has all the device drivers that communicate with your particular hardware. You might have one brand or another brand of printer. You may have one brand, another brand of an Ethernet adapter in your hardware. The kernel communicates with all that stuff, and it's sort of a privileged level communication. Then the thing you see on the screen, that's the user shell, the user interface, like a GUI, a graphical user interface like Windows has. You can drag the icons around, you can adjust the background color of your screen and so forth, and it memorizes all that stuff, puts it in something called the Windows registry. There's also a thing in Windows called the command prompt, the command line interpreter, CLI. Cisco devices don't have a GUI. They just have a text-based. It looks kind of like the DOS prompt. You know, you type DRR, you get a list of files. You type check this, it checks the disk. So every device, no matter what type of software it's running, what type of hardware it has, is going to have this type of structure. Some hardware, some type of kernel that directly has the privilege of handling and communicating with the hardware, and then something the user uses himself to talk to it. So in a GUI, like Windows, we've got, well, this looks like kind of like Windows 10 here. A graphical user interface, kind of user-friendly. You can move and point the mouse. Most people find it fairly easily to point and click with the mouse, as opposed to having to use a command line interpreter to do stuff. So examples are the Windows operating system, the Mac OS operating system, various distributions of Linux, the Apple iOS, which is a little I, big OS, no relationship whatsoever to the Cisco. Apple stole that from us. Not the first thing that Apple has stolen. And the Android operating system. So GUIs have, there's like 100 million lines of code in Windows. That's a lot of possibilities for things that can crash or not work properly. So network devices have to be, they're not only required to be super rugged and operate for 10 or 20 years in a hot room with no attention whatsoever, to reduce the chances of them crashing or failing, we're going to use a command line interpreter to get to that. So in a PC operating system, you could move the mouse and double click on an object. You could also enter text commands by bringing up the command prompt. In a CLI-based system, you would type on your keyboard. You wouldn't use your mouse. Everything would be entered from the keyboard, and you would view the output on the monitor. It would look more like the right-hand side here. This is a screen print from a Linux screen. And the guys that wrote the Cisco OS were the old Unix gearheads, so it has a more of a resemblance to Linux or the command prompt in Windows. Okay, we need to connect to a switch, and we need to set it up for the first time. So the very first thing we're going to do, that blue, baby blue cable, that's called a rollover cable, a Cisco console cable. And one end of it plugs into the baby blue silkscreen RJ45 console port on the switch or router. You plug that in, that looks like an Ethernet connection into the RJ45. It's not Ethernet, it's only a serial port. And the other end plugs into the 9-pin COM1 port on a desktop PC or a laptop PC. Most computers don't have that 9-pin port on them anymore. They just have a USB. So you can get a version of this cable that has the USB plug to plug into your desktop PC. They make a version for the standard USB Type A, and they make a newer version for the USB Type C, you know, the one you can turn it either way, it'll go in. We're going to use this console connection to initially configure the device, because before the device is configured, he has no network connectivity. Once it's configured and it's on the network, you can ping it, it has network connectivity. We can use Telnet or Secure Shell to connect to it after we've configured the passwords and allowed that to take place. Telnet is has a problem in that it's plain text and unencrypted. You could run the Wireshark program that I mentioned, and you could see someone's passwords and all the data that they're sending. Okay, in a sandbox situation like we're doing in the lab, it'd be fine. In a real production network, you would probably want to use Secure Shell. It's like Telnet, but everything's encrypted. Names, passwords, everything is encrypted. That's why it's the recommended method for remotely connecting to a device and managing it. If you don't want to run down to the network operations center where the device is physically located and lug your laptop in and plug it in the console port, you can just remotely log into it using Telnet or Secure Shell and work on it that way after it's been configured. To connect to a device, you need a terminal emulation program on your Windows PC, whatever device you're using to connect to it. TerraTerm is the one that most of the labs are written, and assume you have that program. Microsoft comes with a program called, what is it called? HyperTerminal. It's hidden by default, but you can bring it up if you need to. It has a bug in it, but there's a bug fix version available. Putty is probably the most famous industry standard method of remote connecting to devices. The one on the right, TerraTerm, is the one that we'll use in our labs. If you use packet tracer, you're going to use a different method because packet tracer is a sort of an emulation or a simulation of actual devices. Again, these would be used to connect to the device initially, to the console port, serial port, and configure it, and then later on to remotely access it over the network. Now let's look at iOS navigation itself. When you first log into a Cisco router or switch, and it's brand new with no configuration on it whatsoever, it has some modes of operation. When you first attach to the device, it's going to be in something called the user exec mode. And you notice on the right there, it has that greater than symbol that's on it. That tells you in the user exec mode, that prompt. And by the way, the default host name of a router is the word router, and the default host name of a switch is the word switch. And the greater than sign means I'm in the user exec mode. I can't make any changes. I can just look and show some things. This is a safe level of access to give to your help desk staff people, for example. They just want to check the status of a device, but you don't want to give them the privileges to be able to actually modify the device. To be able to modify the device and do the real work on it, we're going to promote ourselves to the privilege exec mode. We're going to type the command enable, and the prompt is going to change to the # prompt. We're going to put a password on this. So when you type the command enable, it will ask you to put in the correct password. And once you supply the correct password, you will be at the # prompt. And we're probably going to change the default host name from router to maybe R1 or R2. And we'll probably change the host name of the switch from S1 or S2. But you can always tell you're in the privilege exec mode because it has that # prompt on it. Once you're in the privilege exec mode, we can now go into some configuration modes and actually set things up. So I want to go to the global configuration mode, configure terminal, config T for short, and the prompt is going to change to the host name of the device with the word config in parentheses and the # prompt. This is where I'm going to do my configuration tasks. I'm going to set the host name of the device to S1 perhaps. I'm going to set the IP address of a port, so it has an IP address on the network with interface configuration mode, config-if. I'm going to go into the config-line mode and set the passwords for being able to come into the console or be able to come in through telnet access. To be able to go from the user exec mode to the privilege exec mode, let me see, can I turn on my little pencil here? Here we go. So let's say I'm in the user exec mode right here. And I want you to get to the privilege exec mode. Now, when you first have a new device that's erased and has no configuration, there's no password yet. So you're going to type enable, press the enter key, and you immediately will see #. Now I want to go to the global configuration mode. I'm going to type the command configure terminal, or config T for short, and the prompt will change to switch config. Looks like over here. If I want to go back to the regular privilege exec mode, I can just type the word exit, and that'll exit me back to the previous level. Now, let's say I'm in a line configuration mode and I've been setting passwords for the console port so that if someone gained physical access to the device and they plug that baby blue cable in, would they be able to configure the device or change it? Not if they don't know the password, they won't be able to. So let's say I'm in the console line mode, config line mode. I type the word exit, that'll back me off one level. Sub-configuration modes are to get to if I want to go back and I'm really deep in a sub-configuration mode, config line, config IF, and I want to get real fast just to the plain privilege exec mode because I need to maybe back up the configuration or do a show command, I can either type the command in, or I really like Control-Z. Control-Z is hold down the control key like it was a shift key, and while holding the control key down, touch the letter Z, and then I'll pop you right back to the privilege exec mode real quickly. I can also type in, if I'm in the configure line mode and I was doing a password, I can type interface fast Ethernet 01. It'll take me straight to, well, that's an interface, so it'll change the prompt to config-if. Now let's look at the command structure for entering iOS commands. So here's the prompt. It's showing us that we're at the switch prompt. He hasn't changed the host name yet. That's the prompt right here. And we're going to type a command. Don't worry, we haven't covered all these commands yet. Show is a command. It's in purple. I want to show something. I want to show all the protocols that are running on this particular machine. I type the word show, and I put in a space right here. And then I type the argument or the keywords. I want to show IP space protocols. So I type those two words and press enter. And it'll show me all the protocols that are running on this machine. Here's an example of another command. I want to ping. I want to do a ping and test network connectivity. Ping is a utility that allows us to check end-to-end network connectivity between two devices. So I'm at the prompt, switch. I type the command ping. And what do I want to ping? I type the IP address of some other device I'm trying to ping. I'm trying to test network connectivity. And then if we have network connectivity, the ping command will tell me that has connectivity on the screen, or it'll tell me that he doesn't have connectivity. In the Cisco iOS, exclamation marks are it was good, and periods are it failed. So a command could have more than one argument. So we can have us. Hold on, somebody joined. I got to do attendance. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So in the reference, it tells you that the command itself is in boldface, and then the italics is what you type in as the arguments. And some things are optional as well. This sounds like we're taking a programming class. This sounds confusing to me. Okay, so for example, ping, the command ping is the command. And I want to ping a certain address. So ping, the italics is, don't type IP-address in italics. No, you're going to type 192.168.1.1 or something like this. You're going to type in the address you want to ping. There's another command that's similar to ping called traceroute, which is, I call it ping on steroids. Ping will tell you whether you have end-to-end connectivity from one device to another device, but if there's a failure in between, it won't show you where. Traceroute will show you all the routers between you and the device you're trying to ping. Keep in mind, there's usually about 10 routers between you and your favorite web server, and it'll show you where the failure in communication has occurred. There's a wonderful built-in context-sensitive help feature in iOS. If ever you run into a problem and you don't remember the name of a command, or you don't remember what you're supposed to type next, just type the question mark, and it will do two things. It will show you the built-in help, and then it will repeat the line that you type below with a space, ready for you to type in the next thing that you're supposed to type that he just told you. If you make a mistake, like typing a misspelled command or something, the Cisco iOS will show you right here with this up arrow indicator. He'll say, that's where I lost my mind. So for example, this user has typed, he's typed interface fast Ethernet 01, but he's not at the global configuration mode. He's in the privileged exec mode. So he's saying, well, that's not a valid command. There are some hotkeys and shortcuts. For example, I can type, instead of configure terminal, I can type CONF space T, because that's a legal abbreviation. Now, I can't type just CON, because CON is too ambiguous. It could stand for configure or connect. Which one did you mean? Well, CONF is unambiguously configure. It couldn't be connect, because connect is not spelled the same, 4 letters. So you're allowed to abbreviate as much as you can. And you can save some typing that way. You'll get really fast with your typing. If you type a partial abbreviation, a legal, allowable partial abbreviation for command, and you want it to appear on the screen in the whole, you can use something called tab completion. I can type in CONF and touch the tab key, and it'll pop out configure on the screen. And then I can do a space and T and press the tab key, and it'll show configure terminal on the screen. Very handy, makes you look like a very fast typist. I can make if I make a mistake, I'll take the backspace key. If I want to move to the back, I can use the left arrow key or Control B as the old word start command. Move to the right with right arrow, Control F. The up arrow key will show me all the commands I've typed previously. So if I wanted to not type ping 192.168.1.1 again, I could press the up arrow key and press enter, and that would repeat the last command. By the way, this works in Windows as well and most other operating systems. When you type a command that shows you, it's going to show you more than one screen full of data, it'll print the whole first screen and then it'll stop and it'll put this more prompt on the screen. And what you do next is, this is a complete reverse to what your intuition is telling you. You used to Windows saying, press the enter key to continue, and you get the whole next screen. Well, the gearheads, the Unix gearheads that wrote the iOS use the old Unix method, which is, if you put the enter key, you just get the next line. Line by line. If you want to see the whole next screen, hit the space bar and you'll get the whole next screen. If you type anything other than the enter key or the space bar, it's going to simply go back to your prompt. Any other key will do this. Now, some other useful keys for getting out of something. Control C. If you're in any configuration mode, this will return you to the privileged exec mode, equivalent to Control Z. If I type Control Z, no matter how deep I am in the configuration mode, it's going to pop me back to the regular privileged exec mode where I can do a copy, run, start, and save it or something like this. If you get stuck in a loop, say try to ping something that doesn't exist, you can type the command sequence Control-Shift-6, and this would break it. It will, I shouldn't say break it. It will abort it very quickly, where you can get back to your screen and type the next command. You won't be in the penalty box for a couple minutes. There's a couple of Cisco gotchas where he sometimes seems to trap you for a couple of minutes. It can be very upsetting when you're trying to get something done quickly. Okay, let's look at some basic device configuration. Hang on this 1 second. So let's look at device names. The default device name for a switch is switch. The default device name for a router is router. We're going to look at switches right now. So the very first thing that you do when you configure a device should be give it a unique host name. We'll probably change our switch to S1, for example, in the first lab. So by default, all devices get a factory default name. Switches are switches, routers are routers. So here's the rules for these naming. You have to start with a letter. No spaces allowed. Have to end with a letter or a number. You can only use only letters, digits, and dashes, and it has to be 64 or no characters. And if you want to go back to the default host name, just say no host name. The Cisco iOS is set up so that pretty much if you want to reverse anything you did in the past, just repeat the command and put no in front of it, and it'll reverse it back to what it was before. Now, we're going to do some passwords. Now, I mentioned we're going to use Cisco and class. We're always going to set our console password to Cisco, and we're always going to set our enable password to class. This is so that if you complete a lab in the classroom and you forget to erase your router or switch before the other class comes in and use it, they'll know the password is going to be Cisco class. They can come in, they can erase the device and get to work right away. Don't get the advanced Cisco guys mad at you. They know all the tricks. They can hose your router so that it'll never work for you again. So always use Cisco in class and don't use any other combination of passwords. Now, in the real world, you're going to use more complex passwords that are more difficult to guess. So generally speaking, we want to use passwords that are 8 or more characters. Some combination of upper and lowercase letters, numbers, special characters, kind of like the passwords we make you make up when you log on to WebAdvisor and you made up your password. Don't use the same password for all devices. And don't use a dictionary word or common word because they're easily guessed. So 10 million people who've been through the academy already know about Cisco in class. So use something, by the way, when you go to work for a company, they will probably have a password policy that you're required to comply with. Like when TCC students are required to make up passwords that have to have one uppercase character, one lowercase alphabet character, one number, and 1 special character, 3 out of 4 of those. That's our password rules, and 12 character minimum limit. Okay, so here's how we do this. We're going to configure the password for the console port. Now, when you first connect to the device, you're going to connect your console port to the console port of the switch, and you're going to run term on your PC. If you're using Packet Tracer, you can simply click on the device and go straight to the CLI on the device without having to use the term program. But on real devices, we have to have a real laptop or desktop PC to connect to it first. So let's assume we're in the lab, and I've connected my desktop PC to the lab rack in the back of the room, and I've fired up the term program and chosen COM1, and I've got the prompt on the switch, and I need to configure the passwords. Okay, remember we were told to do the host name first? Do that first so you don't get mixed up between switches. Okay, I want to set the password for the console port. So I go to Configure Terminal. The prompt changes to config. I type line console 0, and I type password Cisco. That sets the password to the word Cisco. And then I type the command login, which means let people log in using that known password. And then I type end, and it takes me back to the privileged exec mode. Okay, that sets the password on the console. Okay, that's going to be Cisco. Now I want to set the password for being able to go from the user exec mode to the privileged exec mode. So I'm in the privileged exec mode, # configure terminal, enable secret class. And that's going to set the password to, when you tap enable to go to the privileged exec mode, you have to know the passwords class to do that. So those are the 2 basic commands we're going to use in our labs to protect them. In the real world, you'll use more complicated passwords than that. Now, let's say I want to have a VTY, which stands for virtual terminal. I want to have VTY access to this switch so that people can come in using Telnet or Secure Shell and connect to it from a remote location. So maybe I want to give my help desk staff people access so they can show the routing table on the router, or they can show the MAC address table on the switch and check things out. But I won't tell them the enable password because they don't need to be working on that. They're not an authorized Cisco technician or engineer. So here's how we do this. We're going to go to the global configuration mode, configure terminal, and then instead of saying line con 0, say line VTY 0 through 15. There are 16 slots that you can connect to. They're all going to be set to the same password, Cisco, same password used on the console port, same command login. And now when I connect to this device, I will be able to connect to it remotely from another location over the existing network connection. That way you don't have to run physically down to where the device is located in order to maintain it or configure it. Now, these passwords are shown in plain text form. The exception is the enable secret class password form hides the password so you can't see it on the screen very easily. We want to hide all the passwords, not just, we want to hide the console password and the terminal, virtual terminal passwords as well. So we're going to go to the global configuration mode and type the command service password encryption, and that's going to, instead of Cisco and class, now they're configured where you can't tell what they are. So this way people can't look over your shoulder when you're doing a show run and see what's going on in the machine. Or if you type out on a piece of typing paper or printed paper, you type the configuration of the device, they won't be able to see that, oh, it's Cisco, it's class, and they can try to tamper with the system. Okay, story time. Back in about 1990, I took a C programming course at UTA, and I had my first dial-up account ever. Oh, with the Screeching Cats dial-up modems thing. And it was on a VAX computer. So they gave me a dial-up access to the VAX machine. And I dialed up from my, this is back in the days of StarText and America Online and stuff like this before the internet really took off. So I dialed up and they gave me an account name and a password to dial into, I did my C. This is an old version of, what's C now? C++? Isn't that a popular programming language? I think it was C minus, really old version of C. And I would log on to the UTA Computer Center, and it would put a message on the screen that says, welcome to UTA Computing Center. The system will be down Sunday morning from 2 a.m. to 3 a.m. for maintenance. Otherwise, you're good to go, buddy. Take off, knock yourself out. Well, that was a nice greeting message, and that was a banner of the day from the VAX system at UTA. Unfortunately, some people decided they're going to break into the system, and so some hackers from Germany or something like that broke into the system, did some damage. They were caught, hauled into court. A great book on the subject is called The Cuckoo's Egg by Clifford Stoll, if you want to see how that worked out in the early days of hacking. They were hauled into court, and they stood before the judge, and they said, "Your Honor," it said, "welcome." The message said, "welcome." And the judge says, "You're right. You guys are free. You are not guilty." The message said, "welcome." So since that time, everybody has changed their banner messages of the day. They no longer say, "welcome." They now are nasty. They're nastygrams. Authorized users only. Everything is being tracked. If you disagree, log off now. So on Cisco devices, we can put this banner message of the day, which is a message that anybody that somehow figures out how to connect to the device, they don't know the password yet, they're going to get a message that appear on the screen before they even attempt to try to log in. The message will be written by the lawyers for that company. The lawyers will tell you, they will have done their due diligence, and they will tell you what you need to say on your machine. So we're going to say something in our labs. We're going to practice. We'll say authorized users only, something of that nature. So you can use it, go to the configuration mode, and then say banner message of the day, and then put your message and put a unique character before and after. We have a pound sign before and a pound sign at the end. It can be any character. We can use the pound sign, we can use the @ sign, any character you want, and you'll put your message in between those. And then when the user's attached to the device, before they ever get a chance to put in the password Cisco, they have been legally warned. They have seen the message before they ever logged in. So that's a CCNA objective, being able to do the banner message of the day. Now let's save our configurations. There are 2 system files that have the configuration in them. When you type in, as you type in commands onto a new device, it's stored in the RAM memory of that device. And RAM memory is temporary memory, okay? So when I turn off the device, the RAM sort of evaporates away instantly. All that stuff you see on those crime shows like CSI Tulsa, where they run in and they spray Freon on the RAM chips and they recover the message that was in the computer, that's bogus nonsense. RAM memory needs to be refreshed 1,000 times a second. As soon as you turn the power off, RAM memory is gone. So if you're working on your Microsoft Word document and you just pull the plug on the computer, what happened to that print? Oh, that was my dissertation that was due tomorrow morning, and the dog unplugged the computer. Well, you've lost it. You didn't save it. So on Microsoft Word, you would click File, Save, and save your document. So on the Cisco devices, all the commands you've typed in so far, we typed in passwords and maybe put in an IP address. That's in the random access memory. That's called the running configuration, the current configuration. It takes effect instantly. When you type effect, it takes effect instantly, but you want that to be retained in case the router reboots or power's lost and comes back on again. So in order to save the changes, in a Microsoft Word, we're going to type save and save it onto the hard drive on a Windows computer. Well, Cisco devices don't have hard drives because hard drives have spinning rust in them and they can break down. They use flash memory instead. So we're going to type, or in VRAM memory, non-volatile memory. So I'm going to type the command copy, run, start, and that's going to take the entire configuration that's in RAM memory right now that that's worked hard on for an hour, and it's going to save it to the NVRAM chip on the computer or on the Cisco router or switch. And that way, when it starts up again, it's already saved, and you'll have to type it down all over again. That's called the startup configuration file. It's saved in the NVRAM. It's kind of like flash memory. It doesn't lose its contents when it's turned off. Now, I can always, let's say I'm finished with a device and I want to restore it for the people in the next lab to use because I'm a good lab citizen. Or let's say I just horribly hosted up so bad that I want to start all over again. So what we're going to do is I want to restore the device to its previous configuration. If I've saved something to the startup configuration file, if I haven't saved anything to the startup configuration file yet, doing a couple of start, I'll just reload it. It'll reload back factory fresh. I can start all over again. It takes about 3 minutes to reload. If I have saved the configuration and I just did something terribly wrong in the lab, I need to set it back to its factory fresh condition. I'm going to type the special command erase start, and I have to press enter 2 times. And it'll erase that NVRAM. And then I can do the reload command and it'll be factory fresh again. This is what you should do whenever you finish any particular lab. Now, it's also possible that you can save the configurations on your device. You're going to work in the lab on Wednesday, and the advanced Cisco guys are going to be on Thursday working on your devices. You can save the configuration you did on Wednesday and restore it when you come back next week. So you can go into your communication program. He's showing Putty here, but territory is similar. And you can save everything that appears on the screen to a text file, like a notepad file. And then you can copy and paste it back in later. So that's an option that you can do that. And we give you Microsoft, what's it called? Microsoft Drive, that, and we give you, we also are giving you guys free Gmail access and Gmail and Google Mail files, but those are going to go away next year. We're going to go over to Microsoft. You guys are going to get free Microsoft accounts sometime next year. Or you can just bring a flash drive in the class and save it to your flash drive. So this user has said save everything to a text file, and then he types show run on the screen, and then saves that to a notepad file. And that can give you a record of something. You can use our free printing service there in the lab and print it there. Not like the WEPA printer upstairs that charges you 50 cents a page. Okay, let's look at ports and addresses. IP addresses. Oh no, binary math already. Oh no. Oh, that's right. That's next Monday. So IP addresses are the way that we represent, and I'd like to say that IP addresses is kind of like telephone numbers. A telephone number has got 817 is the area code prefix, and 515-4445 is my office number. So IP addresses are kind of like that. Some of the left part of the IP address is your network, your company network, and then the right part of the address notifies which server, which workstation is it. And the way that these guys came up with this is they knew that people didn't like working with binary numbers, so they used decimal numbers. People are used to decimal numbers. So IP addresses represent a 32-bit IP address with 4 dotted decimal numbers. Now, with 4 binary bits, we'll see this next time, the biggest number you can have is 255. So there's never a number bigger than 255. So the IP address, the 192.168.1.10, that's the unique individual host address of this computer at this location. And the subnet mask, I don't like the word mask. It sounds like it's the Phantom of the Opera is trying to hide something from us. I would rather it be called the subnet yardstick or the subnet ruler. It's telling us how big the network is. This subnet mask is telling us that this is the network prefix part here that we can't change. But these last 256 values, I'm 10, my neighbor's 11, the server's 1, we can change those numbers. So the default gateway address is something we haven't talked that much about routers yet. To be able to communicate with anybody that's not in your room, that's on the rest of the world, you need what I call a friendly neighborhood router. Routers used to be called gateways. Switches used to be called different names. So default gateway really means default router. That's the router that you're connected to. Your home router is your default gateway. And I bet you it has this number right here. I bet you that if you did an IP config on your home machine, it would tell you that your default gateway is 192.168.1.1 because most home routers are configured with that address. That's the relay point that will send your message to any other place. And your default router has got the routing table and you can communicate with the rest of the world. Now, there is a second form of IP addresses that they started in general use around the year 2000 because these 32-bit IP addresses, do you remember back in the 90s when we ran out of area codes? And we had to have, and now we have 6 area codes in Fort Worth. We used to just have 817. Now we got a bunch of others. Everybody got fax machines. and pagers and dial-up modems, and we ran out of phone numbers. There weren't enough digits, so we had to put in new area codes. So the same thing happened with the IP version 4 addresses. This 32-bit thing, even though it has 4 billion possible combinations, we ran out of numbers. So going into the future, on a going forward basis, as Dilbert's boss said, let's do this on a going forward basis, and Dilbert tells us, boss, thank you for ruling out going backwards in time and time travel. So IP version 6 is a newer addressing scheme that has 128 bits instead of 32. So that's why thermostats and refrigerators and TVs and stuff all have IP addresses now. So we have so many numbers that we can give everything. Parking meters, everything can have IP addresses. So IP version 6 is generally going to replace IP version 4. But in the meantime, there's a lot of legacy. And when I use the word legacy in this course, of course, you will think about something that's totally obsolete and should be gotten rid of as soon as possible and upgraded. So a lot of IP version 4 is still around. We'll use that at first just to get used to it. And then we'll also talk about IP version 6 as we go into the course. Interfaces and ports. I sometimes mix these devices up. So a hole in the box that you plug a wire into, is it an interface or is it a port? So yeah, generally I call them both the same thing. Technically speaking, the interface is the Ethernet one and the port is the console port. So what kind of media can we plug into these devices? RJ45 connector, we probably plug an Ethernet cable into it. The fiber optic cable has its own particular type of plug that we could plug into that. We could use Wi-Fi. How would you choose between one of these and others? It depends on some considerations. How far do we need the signal to be carried? Copper cable can go 328 feet. Fiber optic cable can go miles. Wi-Fi can only go a couple hundred feet. What about the environment in which the media is to be installed? Twisted pair copper cable works in almost all environments just fine, even though it's next to a 277-volt lighting fixture. If it's next to a welding machine, we might need to use shielded cable or fiber optic cable. What about the amount of data and the speed? Copper cable is pretty much limited to, well, we use copper cable in our lab and our workstations are 1 gig connected to the county production network. If I want to go 10 gig or 100 gig, I'm going to have to use fiber optic cable. And what about the costs of the media and the complexity of installation? Gosh, twisted pair cable is pretty easy to crimp an RJ45 cable on. I'm not going to bother. I'm going to go to Monoprice and buy one at 47 cents. Fiber optic cables are much more difficult to install and maintain properly. We need to have the pros work on that. Now let's look at the subject of configuring IP addressing. So here's a screen print of what you would see on a Microsoft Windows computer if you went into the network control panel and you were going to configure the IP addresses. Because one of the objectives of CCNA is to be able to configure a certain IP address on a Windows workstation. In the labs, we're going to use routers and switches, and we're going to use Windows 10 workstations. So end devices need an IP address if they want to communicate with other devices. Typically, we have we'll call the first PC PC-A, we'll call the second PC PC-B when we have our test labs. And the first PC will normally be 192.168.1.10, and the second PC will typically be 192.168.1.11. And typically our default gateway will be 192.168.1.1. So to do this on a Windows PC, and Windows, by the way, has 7 different ways of doing everything. So we could go into the control panel, network sharing center, change adapter settings, choose the adapter, right-click on it, choose properties, local area network properties. Finally, we're here and we can do it. Then we can configure it and click OK, OK, and so forth. I have put a handy shortcut on all of the virtual machines that we'll be using in the lab to snap straight to the screen very quickly. And if you're using Packet Tracer, there's a screen in there that goes to it very quickly as well, where you can configure the IP version 4 or IPv6 addresses on your particular device. Now, in the real world, we normally don't statically configure IP addresses. We normally want a server to do it for us. At home, your home router automatically gives out perfectly valid, usable IP addresses to all the devices you have at home, using some protocol called Dynamic Host Configuration Protocol, DHCP. By default, all devices are configured to be a DHCP client and accept a valid address from the DHCP server. This is a big boon for us network technicians and engineers because we used to have to statically configure everything. Up to about, 1995 or so, I had to statically configure everything. And in industry, 50% of your people move every 6 months and they need a new address now. And by the way, these are Macintosh people. They already know everything there is to know about computers, so they don't put the right settings in. So to access a switch virtual interface, I'm going to give the switch a management address. So here we are at the switch. We haven't changed the host name yet. Probably the S1 in the lab. We're going to say configure terminal. And then I'll say interface VLAN 1. And then I'll assign it an IP address. And then I'll give the no shutdown command, which energizes that network connection on the switch. Now I can log into the switch with Telnet or Secret Shell. I can ping it and make sure it's alive on the network. So that's some very basic configuration stuff. And in Wednesday, we're going to do some very basic configuration of a switch in the lab or on Packet Tracer. If you do it on Packet Tracer, do it remotely. Okay, let's see. Hang on just a second. I'm going to check to see if I've missed any questions. Okay, hold on. I'm going to stop recording.